Hi, my name is Michelle Jenkin, and this is my Lab 3 report. For this lab, I explored the magnetic field of a permanent dipole magnet and discovered the relationship between distance and a magnetic field due to a dipole. In order to complete this lab, I utilized a magnetometer app called Tesla Meter. The two fundamental physics principles I used in this lab were Biot-Savart's law and equations for distance dependence, which both will be shown in later slides. A quick summary of my results is that I calculated n to be negative 3.6785, mu to be 1.108, and k to be 2.216. To begin the experiment, it is important to note that I have also had to compensate for Earth's magnetic field, so I had to ensure that the magnetic field of the magnet I was using is orthogonal to Earth's magnetic field. This allows me to measure the two magnetic fields from the Earth and magnet separately. With my app, I positioned my phone to align with Earth's magnetic north-south axis. I knew it was aligned once the x component of the magnetometer app was 0. Now I can ensure that my meter stick runs east to west and place my magnet with its axis pointing along the meter stick. Finally, now, with the location of the sensor identified and the Earth's magnetic field accounted for, I can now conduct the experiment and record my observation values. I found distances that were produced a certain x-component magnetic field and then recorded them on the spreadsheet that was provided to me. With my data graphed, I can now determine the value of n, the distance dependence, using my equation. By taking the log of both sides and writing my equation in the y equals mx plus b form, I can deduce that the value of n is equal to the slope of my line. This value was negative 3.6785. I expected it to be negative because the magnetic field decreases as distance increases. I can also determine k to be 2.216, which is e raised to the y-intercept. With my k value, I can now calculate mu, the magnetic dipole moment. Since my magnet was on axis with my phone sensor, I used the equation k equals mu naught over 4 pi multiplied by 2 mu. Solving for mu got me the value of 1.108. The two statements I observed during this experiment is that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. And the second statement is that as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. For the second part of the experiment, I focused on finding the magnetic field off axis. I found a perpendicular distance for which the net magnetic field was equal to 100 microteslas. I then added B Earth and B measured to obtain B corrected on my spreadsheet. For the coding portion of my lab, my task was to create a function to calculate the magnetic field due to a dipole given this formula. I first inserted the value that I calculated for mu in my experiment and created the function to calculate the magnetic field. I then created 6 vectors, 2 on axis and 4 perpendicular to the axis. Next, I utilized my function to calculate the magnetic field at all those observation locations and created an arrow object to visualize this. Lastly, I used my dperp average for my experiment to calculate the magnetic field 45 degrees off axis. Here is a view of my final output. To conclude with, if I had not oriented my experiment to compensate for magnetic north and had laid out my meter stick at some intermediate angle with respect to Earth's surface, the numbers I observed would have been different. This is because the x component will no longer be near zero due to the Earth's magnetic field. If I had stuck 2 identical magnets together and ran this experiment again, I would expect my measurements to be about double in magnitude. This is because the magnetic field with 2 magnets together would create a magnetic field twice as strong. Lastly, some difficulties I faced while completing this experiment was finding an environment with no electrical equipment or metal. I also accidentally bumped my phone into the magnet a couple of times, which then skewed the magnetometer and forced me to start over. Thank you for listening to my Lab 3 report.